Okay, so here is another example on calculation of the empirical and molecular formula. So the example here is an organic compound on analysis yielded 2.04 grams carbon, 0.34 gram hydrogen, and 2.73 grams of oxygen. Then the question A is, what is the empirical formula of the compound? B is, if the relative molecular mass of the compound is 60, calculate its molecular formula. And then we are given that the relative atomic mass of carbon is 12, hydrogen is 1, and then oxygen 16. So the first thing that we're going to do here is to look for the empirical formula, right? So the empirical formula, how do we look for it? There are two main steps in looking for the empirical formula. Number one, you have to look for the mole of each of the elements and then divide by the smallest value, right? So we know that mole is equal to mole is equal to reacting mass over molar mass, right? Mole is equal to reacting mass over molar mass. So we're going to look for the number of moles of carbon in this compound. So since mole is equal to reacting mass over molar mass, what's the number of moles of carbon in this compound? So the reacting mass of carbon is what? 2.04 grams, right? So that will be 2.04 grams. That's the reacting mass over the molar mass. The molar mass of carbon is what? 12. So 2.04 divided by 12 will give us 2.04 divided by 12, that is equal to 0.17, right? So the number of moles of carbon in this compound is 0.17. And then we'll look for the next compound there is hydrogen, right? Hydrogen. So the reacting mass of hydrogen here is 0.34 grams, right? So that will be 0.34, which is the reacting mass over the molar mass of hydrogen, which is 1 over 1. So 0.34 divided by 1 will give us 0.34 moles, right? So this is the number of moles of hydrogen in this compound. And then the next element that we have there is oxygen. And the mass of oxygen here is 2.73. So oxygen. So the number of moles of oxygen is equal to reacting mass over molar mass. The reacting mass of oxygen is 2.73 over the molar mass of oxygen is what? 16 over 16. And that will give us 2.73 divided by 16. 2.73 divided by 16, that is equal to 0.171, right? Approximately 0.17. So that will be 0.17. Then the next thing we should do is to divide by the smallest value, right? So what's the smallest value here? The smallest value is 0.17. So the next step is to divide by the smallest value, right? So if we divide by the smallest value, this will be 0.17 divided by 0.17, which is the smallest value. Then hydrogen will be 0.34 divided by 0.17, which is the smallest value. Then oxygen will be 0.17 divided by 0.17. So 0.17 divided by 0.17 will give me 1. 0.34 divided by 0.17 will give me 2. 0.17 divided by 0.17 will give us 1, right? So therefore, the empirical formula of this compound, the empirical formula is equal to C1, which is carbon. That means carbon contains one atom. C1, which is still the same thing as your C. We don't write 1 because 1 is an insignificant number. H2, which tells us that the number of hydrogen here is 2. H2, O1, right? O. 1 times O is still O. So 1 is an insignificant number. So this is the empirical formula of this compound. This is the formula that shows the simplest whole number ratio of each of the elements in this compound. So in looking for the empirical formula, there are two basic things that we do. First of all, we look for the mole. We calculate the mole, which is equal to reacting mass over molar mass, and that is what we did here. And then we divide by the smallest value, right? And that is how we got this formula. Then question B is, if the relative molecular mass of the compound is 60, calculate its molecular formula. So we are going to do B here. If the relative molecular mass of the compound is 60, calculate its molecular formula. So it's very important that you should know that the molecular formula is a whole number multiple n of the empirical formula, right? So from the first question A, we got the empirical formula to be CH2O, right? That is the empirical formula. And here I'm mentioning that the molecular formula is a whole number multiple n of the empirical formula. So the empirical formula is CH2O, right? I will open a bracket close n equal to the relative molecular mass of the compound, which is 60, right? Which is equal to 60. This is how it is represented. Then the next thing is to calculate the relative molecular mass of this compound, right? So the relative atomic mass of carbon is 12, right? So that will be 12 plus hydrogen is what? 1. So that will be 1 times this 2, right? So 1 times 2 plus oxygen is what? Oxygen is 16. N equal to what? 60. So this will be 12 plus 2 plus 16, open bracket close, n equal to 60. So 12 plus 2 plus 16 is what? 12 plus 2 plus 16, that will be equal to 30. So I have 30n is equal to what? 60. So to get my value of n, I will have to divide both sides of the equation by the coefficient of n, which is 30, right? So my n will be equal to 60 divided by 30. 60 divided by 30 is equal to 2, right? So that tells me that my n is equal to 2. So therefore, the molecular formula of this compound, the molecular formula of this compound, which is C2HON, right? And now I have my n to be equal to what? 2 from here, right? I have my n to be equal to 2, so I will put 2 there, right? So that will be equal to 2 times carbon will give me C2. 2 times 2 here will give me what? 4. So that will give me H4. And then 2 times oxygen here will give me what? O2. So this is my molecular formula for this compound. That is very simple and straightforward. So one thing you must remember always is that the molecular formula is a whole number multiple of what? Of the empirical formula. Very important. Okay, so thank you very much for listening. See you in our next video.